Welcome to the CUFSM4 tutorial called The Signature Curve. CUFSM4 was developed by Professor Ben Schafer and the Thin-Walled Structures group at Johns Hopkins University. This tutorial was developed by me, Kara Peterman, grad student at Johns Hopkins Civil Engineering. If you intend to publish any results you obtained using CUFSM4, please reference the following paper. And finally, a look into the signature curve. Here's an example for a cold-formed steel lip channel. As you can see, the signature curve has on the y-axis a ratio of the critical buckling load to the yield load. On the x-axis, we have the half wavelength in terms of length. This first minima corresponds to the local buckling minima, the second minima to distortional buckling, and out here, we have Euler buckling or global buckling. How does CUFSM do this anyway? So rather than using the traditional finite element method, CUFSM uses the finite strip method, which takes that sine function there and uses it to approximate displacements along discrete strips along the length of the section. But rather than get into more detail on this subject, let's take a look at the program. For that, we head to Matlab. So here I am. I'm just going to type in CUFSM4 into my command window, and up pops the introductory page. So basically, since we're starting from scratch, we're going to start by inputting a section. From here, the program flow moves from left to right. If you already had a section you'd made, you'd start by loading that section here. But since we don't, to input we go. This is the default page for CUFSM4. As you can see, it has material properties filled in, nodes fleshed out, and elements. And we have a channel section with lips ready to analyze. But let's go into how we can change these values. So here, material properties is where we define our modulus of elasticity, Poisson's ratio, etc., etc. This is also a good place to define what units you want to use. In this analysis, we'll be sticking with kips and inches and KSI. However, if you wanted to switch to newtons and millimeters and megapascals, you could easily do so by defining your material properties in terms of those units. Here in nodes is how we define the geometry of our cross-section. So in this column on the left, we have the node number. Then it's x location, z location, a couple of degree of freedoms, and finally the applied stress. So for example, node 1, if I wanted to change its x location to, let's say, 4, it's easy to do. I just hit update plot, and you can see the plot reflects my change. But I like that lip channel we had earlier, so back to 5. Now here in elements, this defines connectivity. So for example, element 1 connects node 1 to node 2. It has a thickness of 0.1 inches. So maybe I want something thicker. Maybe I want a beefier section. I'll change that to 0.5, update plot, and you can see there you have it, thicker element. Now CUFSM4 has an easy way to apply your load. Here on the applied load button, it says there, select to generate the applied stress. Sounds great. So here's our little calculator. What we like to do in the Thin-Walled Structures group is put in the max yield stress of the squash load, which in our case is 50 KSI. We use the calculator to calculate the axial stress and the bending moment, and there you have it, easy. In this case, we'll just stick with axial load, so I'll uncheck everything but P. If I like what I see, which I do, I'll submit stress to input. You can see here that this stress has now been applied to every node that I've specified. Adding a node is easy. I simply make a new line, type in the node, and all of the coordinate information. So say I was just curious, what's the area of my section? Well, CUFSM4 can do that for you too. You just hit section properties and everything just pops up. So now we'll head to boundary conditions. We've pretty much exhausted everything we need to do on this page. Let's see how we want to fix our beam. So those of you familiar with previous versions of CUFSM might realize that this page looks a lot different. That's because CUFSM 4 has been modified to accommodate any boundary condition. Today, since we'll be working only with a traditional signature curve and not getting into any of the fancy stuff, we'll just make sure that this solution type signature curve is checked, and save the rest of this page for a later tutorial. The same for the CFSM button, the constrained finite strip method. You'll see more on this in a later tutorial. So finally, we're ready to analyze. And ta-da! As you can see, here's our signature curve down here. We have a distinct local minima, a distinct distortional minima, and a nice global buckling region. So say I wanted to obtain the local buckling mode shape that governs this cross-section. Well, I would just move my red dot all the way over to the minima, hit plot shape, and I can see how this section buckles. Down here it tells me that the load factor is 0.36, and this occurs at a half wavelength of 7 inches. So anyway, that's an easy way to create a signature curve using CUFSM4. Other tutorials will delve into more advanced topics, but now you can create the classical signature curve for any cross-section you input. Thanks for looking up CUFSM4, and good luck!